Hey guys, welcome to my YouTube channel. I'm Aranga here, and in this video, we will talk about hyperthreading, guys. I will try to explain hyperthreading as quickly and as simply as possible. I will not take much of your time, guys, and yet I will try my best to make you understand hyperthreading in a very simple manner. So make sure you watch this video till the end, and also if you end up liking this video, hit on the like button and also consider subscribing to our channel, guys. Now let's head into the video. So before talking about hyperthreading, let's actually tell what a thread is first. A thread is a path of execution. So most of you would not have understood what this means. However guys, by the end of this video, you will be fully aware of what a thread is and also what hyperthreading is. Now guys, let me actually give you a very simple example. So guys, now let's take an example guys. Now let's say you are going to a cinema theater to watch a movie, and the first thing you do is that you go to the ticket counter to buy tickets. And when you go to the ticket counter guys, you will see that there is not only a single ticket counter, but there will be multiple ticket counters like this. And tickets will be issued simultaneously in all these counters. Now let's for example tell that there are 4 counters and there are 4 queues like this, and tickets are issued in all these 4 queues simultaneously guys. Now let's say once you get the ticket, here is the theater itself, and you go and stand in a queue to enter into the theater. So now let's actually see what is the advantage of having multiple queues like this guys. So guys, by having multiple queues like this, the time you need to stand in the queue to get a ticket will be reduced greatly. First point. Second one is that the workload for the person who is sitting behind the ticket counter is reduced greatly. And third is that guys, even if any one of this counter is closed due to any issues, let's say the printer here in the first ticket counter is not working properly, so this ticket counter is closed. However, it is not going to affect the other ticket counters. Tickets can be issued in these other ticket counters without any problem. So guys, these are all some advantages of having multiple ticket counters like this. Now let's actually talk about one disadvantage of having like this multiple ticket counter guys. Now though you have multiple ticket counters like this over here, you have only a single queue to enter into the cinema theater guys. So once people get ticket here, they go from here and stand in that single queue to enter into the theater guys. Now since people are coming from multiple queues and they want to merge into a single queue guys, this will cause a lot of chaos right here guys, because everyone wants to stand in the front of the queue and everyone wants to enter into the cinema theater as quick as possible. No one wants to stand at the very end of the queue. So this will cause a lot of chaos over this place, and to solve this issue guys, the cinema theater management will put a stop here who will ensure that no chaos is caused over here, and who will also ensure the smooth flow of the queue inside the theater, and he will see to that everyone enters into the theater at the right time guys. So this one disadvantage is actually solved by putting a stop right over here. So guys, I hope you would have understood this example of cinema theater, but how is it connected to hyperthreading? Now let's see that. So guys, most of your computer's processors use a design called as pipeline design, and in this pipeline design guys, the flow of data through the pipeline closely resembles the flow of water through a pipeline. Now guys, talking about the flow of water, let's consider a pipeline here like this, and let's say we have a tank here at the end of the pipeline, and water is loaded through this top point of the pipeline. Now you load the water through the top of the pipeline, it flows all the way to the down and enters into the tank finally guys. So guys, instead of having a single point of loading, if you have multiple points through which you can load water, you can actually complete the process of loading water even faster. So now let me actually redesign this pipeline and make it look like somewhat like this. So guys, I hope you can see this now. Now guys, you have 2 points through which you can load water. You can load water through this point also, you can load water through this point also. Now guys, by having 2 points of water loading, you can actually load water simultaneously into both these points. Though yes, at some point they are going to merge into the same pipeline. You can load in two different points guys, and this will make the loading process much faster, as you guys know. So hyperthreading works somewhat similar to this process. Now let's actually see that. So guys, now let's consider this is your processor, and this is divided into two parts like this. Now this is the bulk of the processor where all the execution process takes place, and this one is the front end of the processor. Now guys, this front end, what it usually does is that it fetches data from the memory and it does the decoding process, and after it decodes all the data, it will send it down into the pipeline to the execution stage into the bulk. So guys, this front end is much similar to the loading point of water what we saw in that pipeline example, and this bulk is very much similar to this part of pipeline through which water flows into the tank. So guys, just as we saw in the example of the pipeline, if we have two loading points instead of one, we can load faster. Similarly guys, if we have two front ends instead of one front end, we can fetch the memory faster and decoding process can be done faster. So guys, it was based on this idea hyperthreading was introduced, and in hyperthreading what is done is that guys, in your processor the front end is actually duplicated. So instead of having one front end, it will have two front ends, and having two front ends means that it can fetch two set of data simultaneously, it can decode two set of data simultaneously, and it can, though yes, at some point it will actually merge into a single pipeline and it will go into the execution stage. So guys, just like what we saw in our cinema theater example where we had multiple ticket counters to reduce the time taken to buy a ticket, here similarly we have multiple front ends, and it means that the time taken to fetch data and decode them will be reduced. And guys, the disadvantage what we saw in cinema theater is that it will cause chaos when you want to enter into the theater through a single queue, and the solution for that was putting a staff right here so that he will regulate the queue. And similarly guys, your computer has some algorithm based on which it decides which task is important, and it will prioritize important tasks, and though two front ends do things parallelly and send them into the pipeline, your CPU decides which one is the important task and process that task first. So guys, these front ends are nothing but the execution path. So these front ends are the threads which we talked about at the start of the video. So now let's actually talk about what are the advantages of having multiple front ends. First is that data is fetched and processed faster, and it can be sent into the pipeline faster. And second one is the actual main advantage guys. Even though let's say one front end gets stalled due to some reason, some program is corrupted right over in the one front end, this will not harm the other front end in any way. The processes in the other front end can happen normally, and it will keep on sending the decoded data into the pipeline for execution. So this is one of the main advantage of having multiple front ends or having multiple threads. So guys, this is what hyperthreading is. By having multiple threads, the front end processes like fetching data and decoding can be done simultaneously for a huge amount of data, thus reducing the time taken to fetch and decode data. Though yes, they will be sent into the same pipeline guys, just as we saw in the simulator example where the time taken will be reduced. Here also it is the same thing guys, the time taken will still be reduced, though you need to send into the same pipeline because you process data simultaneously. It can be sent into the pipeline faster and the execution can be done faster than the time it would have taken if it had only one front end. So guys, these are some advantages of having multiple threads in your processor. One is that the data can be fetched and processed faster and it can be sent into the execution stage much faster. And second one is that even if one of your front end gets stalled due to some reason, the other one can keep working without any problem, so that still your data will be set and executed and your computer will not lag heavily or anything like that. So these are the two advantages guys. Now we also have one disadvantage. Having multiple thread means that guys, your computer will generate more heat than it would have done if it had only a single thread. So this one was a major problem in the early days when hyperthreading was introduced, but now this problem has been greatly reduced guys, and the extra heat dissipated by having multiple threads is not highly noticeable. So guys, there are some parameters which decide how effective your hyperthreading is, and one of them is the manufacturing process of your, what do you say, CPU. It is based on what manufacturing process is used to manufacture your CPU. And next thing is the turbo frequency of your CPU. However, leaving these things apart, the general rule is that having two threads in one processor will actually increase the efficiency of the processor by 25%. It means that guys, if you have a single core processor with two threads in it will perform 25% more efficiently and more effectively than a single core processor with one thread would perform. So having a single core processor with hyperthreading is equal to having 1.25 core processor. Make the calculations more simpler, let me tell you, have a quad core processor with 8 threads in it. Now guys, your operating system will see it as an 8 core processor, but it is not true guys, it is only a quad core processor with hyperthreading. And as I said, hyperthreading will increase the efficiency of each processor by 25%. So guys, 4 into 25% is equal to 100%. So having a quad core processor with 8 threads is almost similar to having a pentacore processor, that is 4 cores with 8 threads is almost similar to having 5 cores and so on. So guys, this is all about hyperthreading for now. Hope this video would have been useful for you, helpful for you, interesting for you and informative at the same time. If you like this video guys, hit on the like button without fail and also consider subscribing to my YouTube channel. Hope to meet you in my next video. Till then guys, thank you, take care, bye bye.